When you create a file, its group is set to your primary group. So if you're a member of multiple groups, for example, sales and training group, if sales is your primary or first group, then when you create a new file, it will be in the sales group. If you want to change the group of a file, use the chgrp command. You can see that when I created the sales.data file that it was put in my primary group, which is JSON. I'm also a member of the sales group, so let's change the group to sales for this file. Now we can see that the group is sales, and let's give permissions so that other people in the sales group can edit the file. There we go. So instead of keeping files in different people's home directories, maybe you could have a common place to store these. So on this system, there's a user local sales directory, and you can see that the sales group has read, write, and execute permissions for that. So I'm going to put this shared file in that shared location. Now anyone that is a member of the sales group can edit that file. Let's look at directory permissions again. Permissions on a directory can affect the files in that directory. A common problem is having proper permissions set on a file within a directory only to have the incorrect permissions set on the directory itself. Not having the correct permissions on a directory can prevent the execution of the file, for example. If you are sure that a file's permission is correct, start looking at the directory it's in, and then look at that directory's parent directory, and work your way all the way towards the root of the file system. The permissions are set to 755 on this directory. And if I look in the directory, I see one file, and that is an executable file. And it currently works. So let's change the directory permissions on MyCat to 400. And now I only have read permission. I don't have write or execute permission on that directory. You can see that the only information I get from ls is the file name that is in that directory because of the read permission. Since the permissions are set improperly on the directory, I can't even execute the file that's in that directory. Let's change the permissions to give me execute permissions on that directory. And now we see that it works. And you can also see that ls-l works. The file creation mask is what determines the permissions a file will receive when it's created. If no mask were used, then the default permissions would be 777 for directories and 666 for files. The file creation mask is typically set by system administrators to some sane default. However, it can be overridden on a per user basis by using the umask command. The umask command sets the file creation mask to the mode that you pass to it. If you use a -S, that means umask will display and accept symbolic notation. The mode supplied to umask works in the opposite way as the mode given to chmod. So when you give chmod 7, that's interpreted to mean read, write, and execute permission, or all permissions. However, when you supply 7 to umask, that is interpreted to mean no permission, or all permissions off. So you can think of chmod as turning on or adding and giving permissions, while umask turns off, subtracts, or takes away permissions. A quick way to estimate what a umask mode will do to the default permissions is to subtract the octal umask mode from 777 in the case of directories and from 666 in the case of files. For example, let's take a UMask of 022. If we subtract that from 777, we are left with a default file creation mode of 755 for directories, and 666 minus 022 is 644. So for files, the default file creation mode is 644. If we use a UMask of 002, then we'll have the default permissions for directories of 775 and 664 for files. Using a UMask of 002 is ideal for working with members of your group, since the permissions allow members of the group to manipulate those files and directories that you create. Again, this method of subtracting these permissions is an estimation. So here's an example of using a UMask where this breaks down a little bit. So UMask 007, if you subtract that from 777, you're left with 770 for directory permissions, which is fine. However, 666 minus 007 would leave you with 66 negative 1. So there is no negative 1 permission, there's just no permission. So it breaks down a little bit, but it gives you a good idea of what to expect. Here are some fairly common UMask modes: 022, 002, 077, and 007. This table contains all the resulting permissions created by each and every one of the 8 UMask permutations. If you were to run UMask without any arguments, it will display the UMask in 4 characters instead of the 3 that we've been working with. The 3 characters we've been working with represent user, group, and other. However, there is one other class, and this class is considered special modes. And these special modes are setUID, setGID, and sticky. Just know that these special modes are declared by prepending a character to the octal mode that you normally use with UMask or Chmod. So the important point here is to know that UMask 0022 is exactly the same as UMask 022, or Chmod 0644 is the same as Chmod 644. We're not going to cover these special modes in this course, but I wanted you to be aware that 1, they exist, and 2, they're the reason why UMask is displayed in 4 characters instead of 3. You can see that our UMask is set to 0022. Using a capital S, we can get symbolic mode. Let's see what the default permissions are. The touch command either creates a file if it doesn't exist, or it updates the timestamp of a file. So we see the directory was created with 755 permissions and the file 644. Let's set UMask to 007. Whoops. And UMask of 0007 is the same as 007. And in this case, we can see that directories are created with 770 permissions, and files are created with 660 permissions. Permissions can be represented by symbols or numbers. The effect permissions have on directories is slightly different than they have on files. We talked about how to change permissions with the chgrp command. We talked about some strategies of working with members of your group. And finally, we covered the file creation mask and the UMask command.